Okay guys, so today is our second video on circular measure, and what we're going to be looking at is arc length and area of a sector. So our objectives for this lesson is that students will be able to find the length of an arc given the angle it subtends and the length of the radius. So the angle usually means theta, and the length of the radius usually we're talking about r. We're also going to be looking at area of a sector, so students will be able to find the area of a sector given the angle it subtends, again the theta, and the length of the radius, the r. Or if I give you the length of the radius, the r, and the length of the arc, s, that's going to give you enough information to find the area of the sector as well. Okay, so with that in mind, let's take a look at length of the arc first. So if you recall from the last lesson, we talked about definition of a radian, and the definition of a radian expressed in theta is the length of the arc divided by the radius. So the length of the arc divided by the radius. Now remember, our goal here today is to understand how to find the length of an arc if I give you the angle and the radius. So all we have to do is isolate the s, right? So if I say s and I multiply this r over to the other side, I'm going to end up with r theta, right? Where theta is radius. So this is going to be our first formula that we're going to be taking a look at, which is helping us find the length of this arc if I give you the length of the radius and the angle. Okay guys, so the first example is about arc length. And it reads, the diagram shows part of a circle with center O, radius r centimeters. Calculate the value of r, the length of the radius, and the angle BOC in radians. So let's take a look at the first part, the value of r. And what we can see from this diagram is that this is a circle, right? We've got three radiuses, radii. And we have one arc length from A to B, 2.4 centimeters. We got one arc length from B to C, 1.4 centimeters. And we have one angle here, which is 1.2 radians. So what we're going to want to do here first is solve for r, right? Here we got r is the length of this radius. And of course, this is r, and that is r as well. Well, we know our basic formula for a radian is theta equals s over r, right? And over here, what I do have is I have an s, I've got an arc length, and I've got a theta, I've got an angle. So I can put those two together to solve for the last missing piece, which is the r. So let's just isolate the r. So we'll move the r over here, move the theta over to the other side. We'll end up with r equals s over theta. And then from there, let's just plug in 2.4 for the arc length and 1.2 for the angle in radians. So in this case, we know that r is 2 centimeters. Okay, so we've got r equals 2 centimeters there. Okay, second part, angle BOC in radians. So let's look over here at BOC. Starting here, BOC. So they're asking about, this is the vertex, they're asking about this angle. What is the angle here? So again, let's go back to theta equals s over r. In this case, we're trying to find theta, but we do know s, which is 1.4, and we do know r now. We do know r now, which is 2 centimeters. So 1.4 over 2. And that's going to simplify into about 0.7. Don't forget our units, 0.7 radians. All right, guys, so now let's take a look at area of a sector. Okay? And over here, we're going to take a look at a circle with a sector cut out of it called POQ. And of course, this A denotes the area of this sector right here, with radius r and arc length s. And the first thing we want to do is set up a proportion. And we're going to set up a proportion basically saying the area of a sector POQ over the area of a circle is proportionally the same as the area as the angle in the sector divided by the angle in the circle. And to give you an example of that, if I had a circle, let's say I had a circle of area 4. Okay? If I had a circle of area 4, and I wanted to see what's the area of half of that circle, right? The area of half of that circle, of course, you already know is going to be 2, right? So the area of that sector over the area of the circle is going to be proportionally the same as the area angle in the sector and the angle in the circle. So in this case, the angle in the sector is going to be 180 degrees because it's half of the circle, right? And the angle in the circle, of course, the total circle is 360 degrees. So of course, as you can see here, 1/2 equals 1/2. The proportion holds true. Okay, but now let's look at it in terms of the variables. Okay, so what we have here, POQ, I'm going to say area of sector POQ is, again, our formula for area of a sector we don't know, but we're going to denote that as A. Okay, and the area of the circle, well, we know that because that's pi r squared. Now, angle in sector, what's that going to be? That's our theta. And angle in the circle is, again, we're in radians, so the full circle is 2 pi radians. Okay. Now, what we're trying to do here is set up a formula to solve for an area of a sector. So we're basically trying to solve for A here. So let's isolate A by moving this guy over here. A equals theta over 2 pi times pi r squared. As you can see here, our pi's cancel out. So we end up with an area equal to 1/2 theta r squared. Okay? So that's going to be our first formula. If I give you an angle and the length of the radius, you can tell me the area of the sector. So if I give you r and theta, you can give me the area of the sector. Now, the other thing we can do is we can substitute out this theta, right? Because if you remember, the angle in radians is always equal to s over r. So if I substitute out this angle for s over r, I'm going to end up with A equals, one of the r's is going to cancel out, so 1/2 s r. Right. And that's going to be the other formula that we're going to use in order to find the area of a sector. If I give you the length of the arc and the length of the radius, you can also tell me the the area of the sector by plugging it into this formula. Okay, so for this second example, we're going to try and put all this stuff together. We're going to have a diagram with arcs A, B, and CD are arcs of concentric circles. So imagine this is one big circle and then another smaller circle inside of it with center O. If OA is 6 centimeters, AC is 3 centimeters, and the area of sector AOB is 12 centimeters squared, calculate angle AOB in radians. Okay, so first thing we're going to take a look at is this sector from A to O to B, just this white part, is 12 centimeters squared. And what we're trying to find here is angle AOB. So AOB, vertex O, we're trying to find this theta right there. Well, we have the area, we have the radius. That's probably enough information for us to find the angle, right? So let's turn to our friend A equals 1/2 r squared theta, or theta r squared. And in this case, of course, we are trying to solve for the theta, right? A is 12. Okay. R is 6 squared. And times theta. So, solving for theta, we get 36 divided by 2 is 18 theta. That means theta equals 12 over 18, or 2 over 3. And there's our first part. Our theta equals 2 over 3. Second part, we got to find the area and the perimeter of the shaded region. So that's this part right here, right? BDCA. And let's start by finding the area, okay? Now to find the area, I think it's not that difficult, because if we find the area of this whole sector, ODC, and subtract out the area of the white sector, the 12 centimeters, then we can find the area of just the shaded region. So to find the area of, let's call it COD, let's again turn to our formula. Area equals 1/2 r squared theta. So 1/2. Now in this case, the r is this whole thing, so it's going to be 9 squared. And the theta in this case, we've already solved it, is 2/3, right? So here we can solve for the area. The 2's cancel out. We're going to get 81 up top. 81 divided by 3 is 27 centimeters squared. So that's the area of this whole thing. And of course, we're going to subtract out the 12. So area of BACD is equal to 27 minus 12, which equals 15 centimeters squared. Okay? Last thing we got to find is the perimeter of the shaded area. So that means we got to find the length of this arc, the length of this arc, and of course we already know AC and BD because these are 3 and 3. So we just got to find the length of this arc and this arc. So in order to do that, let's start with our formula. Theta equals S over R, right? And of course, in this case, we're trying to find S. So let's switch that over to S equals R theta. So up here, the arc AB is going to equal radius of OA, which is 6, times the angle 2/3, arc CD is equal to the radius here, which is 9, times 2/3 again, still the same angle. And let's simplify these. Arc AB is length of 4. Arc CD is length of 6. So putting it all together, we got 3 here, we got 6 here, we got 4 here, and we got 3 down there. So perimeter is equal to 3 plus 3 plus 4 plus 6, which is 16 centimeters.